Okay, so let's look at salt hydrolysis. It's assessment statement 18.3.1. Deduce whether salts form acidic, alkaline or neutral aqueous solutions. So, neutralization reactions produce a salt. Salts are ionic compounds. That means they form from a metal and a non-metal. Okay? They have a cation from the parent base. Okay? And they have an anion from the parent acid. So cations are positive and anions are negative. Okay, let's look at an example. NaCl. So how was that made? Well, we had a strong acid and we had a strong base, and that gives us the salt, and of course water here. Okay, now what is hydrolysis? Well, hydrolysis is the reaction of ions with water molecules. So we're going to form H plus or OH negative ions when other ions react with water. Okay, and as you know, H plus makes more acidic, OH negative makes something more basic. So anion hydrolysis. Okay, so the conjugate base of a weak acid is strong enough to hydrolyze a water molecule. So let's look at an example. Here we have ethanoic acid here, and it reacts, it's a weak acid, and it reacts with a strong base to give us salt, okay, which is sodium ethanoate, and of course water. Now that salt will dissociate into the ethanoate ion, okay, ethanoate ion, which is there, and that will hydrolyze water to give us this OH negative over here, which means that it'll form a basic solution. Okay, let's look at cation hydrolysis. So the cations we are going to look at are things like Be2 plus, Al3 plus, and Fe3 plus. Okay, and another example, of course, a non-metal would be NH4 plus. Okay, so the example here is NH4 plus, and this is how we made it. We reacted strong acid with a weak base, and that gives us the salt. Okay, now what's going to happen here is this NH4 plus is going to hydrolyze water to give you H3O plus here, which is acidic. So that's an acidic solution. Okay, now metals with a 2 plus or 3 plus charge are able to hydrolyze water. So like I mentioned earlier, we're talking about Al3 plus, Fe3 plus, and Be2 plus. Now these have a high charge density. Okay, so we can look at complex ion here. Okay, and you've got Fe in the middle, Fe3 plus, and what happens is basically these water molecules, if we look at them like that, the Fe3 plus attracts these electrons here, and because of that, one of these H pluses leaves the water molecule, and we end up with H plus on its own, which will give us an acidic solution. Okay, so the equation for that is down the bottom here, and there's our acidic ion H plus. Okay, so the summary: if you have a strong acid and a strong base, the salt will be neutral, pH 7 at 25 degrees. A weak acid and a strong base, that will give you a basic salt, pH greater than 7. A weak base and a strong acid, that would give you an acidic salt, pH less than 7. Okay.